Now in this lecture we'll find out the area of the green shape. In the drawing we have a circle. The radius of this circle r equals to 2. In addition we have inside this circle peripheral angle ACB. This is peripheral angle ACB that equals to 70 degrees in its size. And we also have here the common extreme point P. From the common extreme point P we have two tangents to this circle, tangent PA and tangent PB. Again, our mission is to find out the area of this green shape. Point O is the center of the circle. We join points O and B together by a straight line. So point O is the center of the circle, point B is the point on the circle itself. Therefore line segment OB is the radius of this circle, that equals to 2 units in its length, according to what is given as a question. We can implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here a circle and we have tangent AB. This is tangent AB that is tangent to this circle here at point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OB that is drawn to point B, that is the point of tendency of tangent PB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals to 90 degrees. According to rule 1, of course. Likewise, we have the radius OA that is drawn to point A, that is the point of tendency of tangent PA with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PA will be perpendicular to the radius AO. If PA is perpendicular to AO, it means that this angle equals to 90 degrees. According to the same rule, rule 1. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same arc. Repeat again on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So, in the drawing, we have a circle. Inside this circle, we have the peripheral angle ACB that is equal to 30 degrees in its size, and this peripheral angle ACB is subtended on RKB. And we also have the central angle AOB that is subtended on the same arc RKB. And therefore, according to rule 13, the central angle AOB will be twice as large as the peripheral angle ACB, because both of them they are subtended on the same arc RKB. And because of the fact that the size of this peripheral angle ACB is theta, therefore the size of the central angle AOB that is subtended on the same arc RKB will be equal to 2 theta. Okay? So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have peripheral angle ACB. This is peripheral angle ACB. This equals to 70 degrees in size. And this peripheral angle ACB is subtended on this arc RKB. And we also have in this drawing the central angle AOB. This is the central angle AOB that is subtended on the same arc RKB. And therefore, according to rule 13, the central angle AOB will be twice as large as this peripheral angle ACB. So peripheral angle ACB equals to 70 degrees. Therefore, the central angle AOB must be equal to 70 degrees times 2, that is 140 degrees. In conclusion, we found out that according to rule 13, peripheral angle AOB will be equal to 140 degrees in size. So I write it down in the drawing. In the next step, we join points O and P together by a straight line. By joining points O and P, we created here two right triangles, the right upper triangle AOP and the right lower triangle, triangle BOP. So in the next step, we will prove that those two right triangles can go into each other. So I write it down. We will prove that the right upper triangle, triangle AOP, is congruent to the right lower triangle, triangle BOP. So why those two right triangles can go into each other? First of all, side AO of the right upper triangle AOP is equals to side BO of the right lower triangle, triangle BOP. Why? Because they are there of this circle, therefore they are equal to each other. So I write it down. Side AO of the right upper triangle AOP equals to side BO of the right lower triangle, triangle BOP. Now move the radii of the circle, that is equal to 2 units in its length. In addition, we have side OP, that is a common side, it belongs to both triangles, so I know that OP equals to itself. It's a common side, it belongs to both triangles. OP equals to OP, it's a common side. And finally, side AP or side PA of the right upper triangle AOP equals to side PB of the right lower triangle, triangle BOP. So PA equals to PB according to rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common external point to a circle are equal. So in the drawing we have a circle And we also have the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. So in our drawing, we have also the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. And PA equals to PB according to rule 2. So actually proved that all the triangles of this right triangle, upper triangle AOP are correspondingly equal to all those triangles, all the three sides of this right triangle AOP are correspondingly equal to all the three sides of this right lower triangle, triangle BOP. Therefore, those two right triangles can go into each other according to side rule. So I write it down. So the upper right triangle AOP is congruent. This is the sign of congruent to the lower right triangle, triangle BOP, according to side rule. And from the fact that those two right angles can go into each other, we derive that those two angles must be also equal to each other. Why? According to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other. Therefore, the two corresponding angles, those two corresponding angles must be also equal to each other. So this is angle AOP in the right triangle AOP, and it is equal to this angle. This is actually angle BOP in the right triangle POP, in the right lower triangle BOP. So if we define one of those two angles as alpha, if this angle is alpha, then the other angle must be also equal to alpha because they are equal to each other. Okay, so if this angle equals to alpha, then the other angle must be also equal to alpha. So if this angle is alpha, then this angle must be also equal to alpha. So alpha plus alpha, this is alpha plus alpha is this angle. And we already found out that this angle equals to 140 degrees. That is to say, alpha plus alpha equals to 140 degrees. So I write it down. Alpha plus alpha equals to 140 degrees. That is to say, 2 alpha equals to 140 degrees. Here we divide this equation by 2. And finally we get that the missing angle alpha is equals to 140 degrees over 2 is equals to 70 degrees. So actually this is the missing angle alpha that is equals to 70 degrees in its size. And this is also angle alpha that is equal to 70 degrees. So in the next step, we'll focus on this upper right triangle, triangle AOP. In the right upper triangle AOP, what is the value of tangent 70 degrees? the value of tangent 70 degrees is actually equals to AP over AO. AP over AO. Repeat again, in the right upper triangle AOP, tangent 70 degrees equals to AP over AO. Tangent 70 degrees is 2.75 and it is equals to AP. AP is the missing side, so we leave it as it is, over AO. AO is the radius of this circle that is equal to 2 units. So we substitute AO by 2. In conclusion, we found out that 2.75 equals to AP over 2. Here we'll multiply this equation by 2. And finally we get that AP equals to 2 times 2.75 is 5.5. So the length of this side AP is 5.5 units. Our mission is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is very easy to see that the area of this green shape equals to the area of the upper right triangle AOP plus the area of the lower right triangle BOP so the sum of the areas of those two right triangles will give us the area of quadrilateral AOBP and the area of quadrilateral AOBP minus the area of this sector AOB will be equal exactly to the area of this green shape. Repeat again, the area of the green shape in total is equals to the area of the right upper triangle AOP plus the area of the right lower triangle BOP. The sum of the areas of those two right triangles will give us the area of this quadrilateral AOBP, and then we'll subtract from the area of this quadrilateral AOBP the area of this sector AOB. It will give us exactly the area of this green shape. Okay. The sum of the areas of the two right triangles minus the area of sector AOB will give us exactly the area of the green shape. Because of the fact that we have already found out that those two right triangles can belong to each other, they also have the same areas. That is to say, the area of the right triangle AOP equals to the area of the right triangle BOP. Therefore, we can substitute the area of this right triangle BOP by the area of this right triangle AOP. We'll do it now and we get that the area of the green shape in total will be equal to the area of triangle AOP, the right upper triangle AOP, plus the area of the lower right triangle BOP. So we substitute the area of the lower right triangle BOP by the area of the upper right triangle AOP. We can do it because they are equal to each other. Minus the area of sector AOB. Here, the rounded line above AOB is the sign for a sector, and the square bracket is the sign of the area. So in total, this expression means the area of sector AOB. So we have to subtract from the area of quadrilateral AOBP the area of sector AOB. So I will present to you the concept of sector. What is a sector? Sector is part of a circle. It is a portion of a circle. We have here a circle, and the green shape AOB is sector AOB. It is part of the circle. This sector AOB consists of two legs, AO, and the second leg is BO. Both those two legs are the radii of this circle is equal to R, therefore they are equal to each other. And this sector also consists of RKB. RKB is between those two legs, AO and BO. And the angle between those two legs, AO and BO, is angle theta. You can look at the sector as a pizza slice. It's exactly the same shape. And what is the area of this green sector, sector AOB? The area of sector AOB equals to pi r squared, that is the area of the circle that contains sector AOB, the green sector AOB, times the angle between the legs of this sector, that is theta, over 360 degrees. In conclusion, we found out that the area of this sector AOB equals to pi r squared times theta over 360 degrees. Okay. So, now the area of triangle AOP plus the area of triangle AOP equals to 2 times the area of triangle AOP, 2 times the area of triangle AOP. It is actually the area of quadrilateral AOBP, and then we have to subtract from the area of quadrilateral AOBP the area of this sector AOB. That is minus the area of sector AOB. So first of all, we have to find out the area of the right upper triangle, triangle AOP. The area of the right upper triangle, triangle AOP. What is the area of the upper right triangle, triangle AOP? The area of any triangle equals to the base of the triangle times the height to the base over 2. So we'll choose the base of this right upper triangle AOP as side AO. So the base is AO. And the height to the base is side AP. Why side AP is the height to the base? Because of the fact that side AP creates 90 degrees with the base AO. Therefore it is the height to the base. So the height is AP, the height to the base, divided by 2. AO, side AO is the radius of this circle that is equals to 2. So we substitute AO by 2 times AP. We have already found out that the length of side AP is 5.5. So it is times 5.5 divided by 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with 5.5. In conclusion, we found out that the area of the right upper triangle, triangle AOP, is equals to 5.5 square units. Two times the area of triangle AOP is 2 times 5.5, that is 11. So 11 square units is the area of this quadrangle AOBP, minus the area of sector AOB. So in the next step, we will find out the area of sector AOB. And 11 minus the area of sector AOB is the area of this green shape. Okay? So what is the area of this sector AOB? The area of this sector AOB is equal to the area of the circle that contains the sector. That is actually pi r square, because r is the radius of this circle, so the area is pi r square, times the angle between the legs AO and OB of the sector AOB. The angle between the legs is 140 degrees. Here it is 140 degrees, as we already found out, according to rule 13. The angle between the legs of sector AOB is 140 degrees. So it is 140 degrees over 360 degrees. So the area of sector AOB equals to pi r square. R is 2. It is the radius of this circle, that is 2. Therefore r square is 4. So in total the area of the circle that contains sector AOB is 4 pi times 140 degrees over 360 degrees. So this expression 4 pi times 140 degrees over 360 degrees is equal in total to 4.888 square units. In conclusion, found out that the area of sector AOB is equals to 4.888 square units, and therefore the area of the green shape in total, the area of this green shape equals to the area of quadrangle AOBP that we have already found out, that is equals to 11 square units, minus the area of sector AOB that we just found out, that is 4.888 square units. 11 minus 4.888 is 6.111 square units. In conclusion, we found out that the area of the green shape in total it is equals to 6.111 square units. Repeat again, the area of this green shape is equal to 6.111 square units. Okay, so in the next step I will summarize the lecture. In this lecture we found out the area of this green shape. So in the drawing we have a circle. We know that the radius of this circle r equals to 2, and we also have inside this circle peripheral angle ACB that is equals to 70 degrees in its size. In addition, we also have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And again, our mission is to find out the area of this plane shape. Okay. So first of all, we join points O and B together by a straight line. What is the definition of line segment OB? Point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius of the circle that is equal to 2 units according to what is given as a question. We can implement here rule 1 because of the fact that the radius OB is drawn to point B, that is the point of tendency of tangent PB with this circle. Tangent PB will be perpendicular to the radius BO. Why? Because the radius OB is drawn to point B, that is the point of tendency of tangent PB with this circle. If PB is perpendicular to BO, it means that this angle equals 90 degrees. According to rule 1. According to the sum rule, we have here the radius OA that is on to point A, that is the point of tendency of tangent PA with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent PA will be perpendicular to the radius AO. If PA is perpendicular to AO, it means that this angle equals 90 degrees, according to the same rule, rule 1. In the next step, I actually presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same arc. Repeat again on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB is equal to theta degrees in its size, and this peripheral angle ACB is subtended on arc AB. In addition, we have in the drawing the central angle AOB. This is the central angle AOB that is subtended on the same arc, arc AB. Therefore, according to this rule 13, the size of this peripheral angle AOB will be twice as large as the size of the peripheral angle ACB that is subtended on the same arc, arc AB. And because of the fact that the size of this peripheral angle ACB is theta, therefore the size of the peripheral angle AOB that is subtended on the same arc will be equal to theta. We can actually implement rule 13 in our drawing. Why? Because in our drawing we have peripheral angle ACB. This is peripheral angle ACB that is equal to 70 degrees in its size. Therefore, according to rule 13, the central angle AOB, here, peripheral angle ACB equals to 70 degrees in its size and is subtended on this arc, arc AB. And we have the central angle AOB. This is the central angle AOB that is subtended on the same arc, arc AB. Therefore, according to rule 13, the size of the central angle AOB will be twice as large as the size of this peripheral angle ACB. And peripheral angle ACB equals to 70 degrees inside. Therefore, the central angle AOB will be equal to 70 degrees times 2, that is 140 degrees. If we found out that the size of this peripheral angle AOB is 140 degrees. In the next step, we join points O and P together by a straight line. By joining points O and P, we get that Here, two right triangles. The right upper triangle, triangle APO, and the right lower triangle, triangle BOP. So in the next step, we proved that those two right triangles can join to each other according to side rule. So why those two right triangles can join to each other? First of all, side AO of the right upper triangle AOP is equal to side OB of the right lower triangle, triangle OBP, because both of those two sides are the radii of this circle, therefore they are equal to each other. Repeat again. AO equals to BO, they are both the radii of the circle, that is equal to 2 units. Therefore they are equal to each other. In addition, we have side OP is a common side that belongs to both triangles, so we can write down that OP equals to itself as a common side that belongs to both triangles. So OP equals to OP is a common side that belongs to both triangles. And finally, side AP of the right upper triangle AOP equals to side BP of the right lower triangle, triangle BOP. According to rule 2, we have rule 2 that states that the length of two tangents from a common external point to a circle are equal. In the drawing, we have a circle, and we have here the common external point, point P. From the common external point, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. We implemented rule 2 in our drawing. We have the common external point, point P. From the common external point, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. PA equals to, that is to say, PA equals to PB. Repeat again. PA equals to PB according to rule 2. In conclusion, found out that all the three sides of the right upper triangle, triangle POA, are correspondingly equal to all the three sides of the right lower triangle, triangle BOP. Therefore, those two right triangles can go into each other according to side rule. Okay? And from the fact that those two right triangles can go into each other, we derive that those two angles must be also equal to each other. This is to say, angle AOP in the right upper triangle AOP equals to angle BOP in the right lower triangle, triangle BOP. And they are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha because they are equal to each other. But again, if this angle is alpha, then the other angle must be also equal to alpha. So alpha plus alpha equals to this big angle. And we already found out that this big angle equals to 140 degrees in its size. In conclusion, we found out that alpha plus alpha equals to 140 degrees. Alpha plus alpha equals to 140 degrees. That is to say 2 alpha equals to 140 degrees. We divided the equation by 2. And finally we found out that the missing angle alpha equals to 140 degrees over 2, that is 70 degrees. So this is the missing angle alpha, that is equals to 70 degrees, and this angle alpha equals to 70 degrees. In the next step we actually focus on this right upper triangle, triangle AOP. This upper right triangle AOP, triangle 70 degrees, what is the value of triangle 70 degrees? Triangle 70 degrees equals to AP over AO. This again, in the right upper triangle AOP, triangle 70 degrees equals to AP over AO. Triangle 70 degrees is 2.75 and is equals to AP. AP is the missing side, so we leave it as it is, over AO. AO is the radius of this circle, that is equal to 2. Therefore we substitute AP, we substitute AO here by 2. In conclusion, found out that 2.75 equals to AP over 2. Then we multiply this equation by 2, and finally found out that AP equals to 2.75 times 2, that is 5.5. In conclusion, found out that the length of this side AP is 5.5 units. Okay? I repeat again that our mission is to find out the area of this grain shape. So what is the area of this grain shape? From the drawing it is very easy to see that the area of this grain shape equals to the area of the upper right triangle AOP plus the area of the lower right triangle POB. So the sum of the areas of those two right triangles will give us the area of quadrilateral AOBP. So the area of quadrilateral AOP minus the area of this sector AOB will be equal exactly to the area of this grain shape. Repeat again, the area of the grain shape in total equals to the area of the right upper triangle AOP plus the area of the right lower triangle BOP. The sum of the areas of those two right triangles will give us the area of quadrilateral AOBP. And the area of quadrilateral AOBP minus the area of sector AOB will give us exactly the area of this of the grain shape. Okay, so actually in the next step I presented to you the concept of sector. What is a sector? Sector is part of a circle. It is a portion of a circle. This is a circle, and the grain shape AOB is a sector. So a sector is part of a circle. The grain sector AOB consists of legs AO and the second leg is BO. Both legs of the radii of this circle is equal to R, therefore they are equal to each other. And it also consists arc AB, that is the arc between the legs AO and BO. The angle between the legs AO and BO is this angle theta. So what is the area of the grain sector AOB? The area of the grain sector AOB equals to the area of the circle that contains the sector times the angle between the legs of this sector, that is theta, over 360 degrees. Repeat again, the area of this sector AOB equals to pi r squared, that is the area of this circle that contains the sector, times theta, that is the angle between the legs of the sector, over 360 degrees. Okay. We already found out that the area of the grain shape equals to the area of the right upper triangle AOP plus the area of the right lower triangle BOP minus the area of sector AOB. But because of the fact that those two right triangles can go into each other, they have also the same areas. So those two right triangles can go into each other, they have the same areas. For that reason, you can substitute the area of this right triangle BOP by the area of the right triangle AOP. We did it and found out that the area of the grain shape in total equals to the area of the right upper triangle AOP and the area of the plus the area of the right lower triangle BOP, but we substitute the area of the right lower triangle BOP by the area of the right upper triangle AOP, because they are equal to each other, minus the area of sector AOB. So the area of triangle AOP plus the area of triangle AOP is 2 times the area of triangle AOP minus the area of sector AOB. In total, it will be equal to the area of the green sector. Okay, so what is the area of the right upper triangle AOP? The area of the right upper triangle AOP equals to, actually, the area of any triangle equals to the base of the triangle times the height of the base over 2. We took the base of this right upper triangle AOP is AO, side AO, and therefore the height of the base is AP. Why? Because AP creates 90 degrees if the base AO. Repeat again, the base is AO and the height of the base is AP divided by 2. AO, side AO is the radius of this circle that is equal to 2. So substitute AO by 2 times AP. AP equals to 5.5, therefore we substitute AP by 5.5. In conclusion, we found out that the area of the right upper triangle AOP equals to 2 times 5.5 over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with 5.5. In conclusion, we found out that the area of the upper right triangle AOP equals to 5.5 square units. The area of this upper triangle AOP equals to 5.5 square units. So we have to multiply the area of the upper right triangle AOP, that is 5.5, by 2. So 2 times the area of triangle right upper triangle AOP, that is 5.5 here. 2 times 5.5 is 11. So 11 square units is the area of this quadrilateral AOBP. And the area of quadrilateral AOBP minus the area of this sector AOB will give us exactly the area of this green shape. Again, the area of quadrilateral AOBP is 11 minus the area of sector AOB will give us exactly the area of this green shape. Okay. So in the next step, we find out. We actually found out the area of this, the area of sector AOB. The area of this sector AOB. What is the area of this sector AOB? According to the equation that I presented to you, the area of this sector AOB will be equal to the area of the circle that contains the sector, that is pi r square. Pi r square times the angle between the legs of this sector, that is 140 degrees. 140 degrees over 360 degrees. So R is the radius of this circle, that is equal to 2, therefore R square is 2 square, that is 4. In total, the area of the circle that contains the sector is 4 pi times the angle between the legs of the sector, that is 140 degrees over 360 degrees. So this expression in total is equal to 4.888 square units. In conclusion, we found out that the area of this sector AOB equals to 4.888 square units. Which again, the area of sector AOB equals to 4.888 square units. And the area of this green shape, in total, it is equal to the area of quadrilateral AOBP, that is 11 square units, minus the area of this sector AOB, that is 4.888 square units. 11 minus 4.888 is 6.111. In conclusion, found out that the area of this green shape equals to 6.111 square units. Okay, thank you very much.